they give you this setup. Pretty standard sort of proportionality, so it's actually not a modified situation, at least not yet. But they're slightly mean in that they say k is negative. That's a pain, isn't it? They give you this equation, but they actually state the k is negative, which is very odd. That's very, very unusual. But what does it mean? You can actually tell me what it means. If k is negative, it sort of implies a negative sign here, right? So what's happening to the population? It's decreasing. And when you read the next sentence, that makes sense. It says the population halves in 3 years. The population halves in 3 years. Okay, now before I account for that, if this is the situation I have got, right, it's not modified, so it's a standard n equals ae to the kt. And normally we would write it as minus kt, indicating that it's decaying, right? But they've accounted for the negative up here. Okay, so just kind of in your mind's eye, see that the negative really is there. Now, if that's the kind of situation, right, they haven't given us any information yet about the initial population, which will be A, okay? So that seems problematic, but we can still account for the information they give us if we think about the fact that when t equals 0, the population will just be A, right? Because this will be e to the naught, so it'll just be 1. So therefore, I can still say, even though I don't know what the number is, when t equals 3, after 3 years, right, the population will be half of whatever it started with. Okay, so this is kind of like the half-life situations. Actually, it's almost exactly like the half-life situations when you look at any radioactive metals, that kind of thing. Okay, so I can use this. I can pop everything straight in and get a value for k. Right, watch. I'll go a on 2. That's my population at that time. Equals a e to the 3. There's my time. K. There you go. Now, being that you've got the common factor of a on both sides, you just divide through by that, and then you take logs. Okay, so you don't need to know what the initial population is in order to work out how quickly it's dropping down, okay? Because the information they've given us, that tells us about the rate at which it declines, okay? I should tidy this up. K is equal to 1/3 log 1/2, okay? Which is a negative number. Now you go to your calculator and you evaluate that and you get out a decimal. You get this decimal. Negative 0.231 blah 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 blah. Okay, now this number is important. This k is so important that they actually call this is confusing, they call this the growth rate. That's a bit weird, isn't it? It's weird to talk about this thing as if it has a growth rate because we know the growth rate is changing constantly, okay? But the idea is that this thing is what defines how quickly or slowly it happens. If I made it a smaller number, it would be decaying slower. And if I made it a bigger negative number, it would be dropping off really quickly. So this number really does define the speed at which the population declines, and that's why they call it the growth rate, okay? So being that it's a decimal, that's a bit of a weird way to say it. They ask for it as a percentage. So all you have to do is multiply by 100, and you get approximately negative 23%. You do have to say it's a negative because they're calling it a growth rate. It's not a decline rate, right? So like I said, that's a bit weird, but they're choosing to use a negative value rather than words to show you that the population's dropping, okay? So there you go. There's the growth rate, negative 23% to the nearest percent anyway. Estimate the population of the colony after 5 years if, and now they give you an initial condition, okay? So if the population is 250 to start with, okay? And it doesn't have to be, but they're just giving that as an idea, right? We can pop this back into, actually, oh, here we go. Yeah, this is where I wrote it, okay? Because we know what K is, we've already evaluated it, and we know what A is because they've just provided it to us, okay? So if that's the case, and they want it after 5 years, you just crunch the numbers. So let's give it a go. Your population will be 250 e to the power of, let's see, 5/3 log 1/2. Chuck that into your calculator. I think for me personally, I did it like this because I just don't like putting so many things in the power. It's a bit awkward and it's more buttons to push. So when you get that, I think you end up with 78 point something. which is your 79. Okay. By the way, this is a good point for me to mention. The whole deal with rounding up and rounding down, especially when you've got objects. I mean, you pretty much always have objects like, what is this? What are they? What are they? What animals are they? Oh, we don't even know. They're animals with some description. Okay. Now, you might be inclined to say, ooh, 78.74, but you can't have 0.74 over an animal, so you might think, oh, okay, I should round down. Okay. Now, when you have a look at the question, the thing is, there's nothing in the question that indicates to you that you need to round it to that whole number, especially when you realize this number is dropping. It's dropping, right? So it hasn't got to 78 yet. Does that make sense? I'm watching this number decrease over time, and when it hits 78.0, that's when I would predict, okay, there are 78 animals left, right? At t equals 5, I'm not at 78 yet. I'm still above it. So even though the model predicts, you know, not whole numbers, I think I'm still up here. Okay? Just as a general guide, if you're ever unsure about should I go up or should I go down, okay? Go up or down, but say what you're doing, right? You would say to the nearest animal, and the most common place where you would explain I'm rounding down or up, even though it's unusual, is where you're rounding the wrong way. If I did round this down, if I rounded it to 78, okay? Because that's not the normal way we round 0.74, I'm sort of obliged to say something to indicate I know what's going on and that I'm not just bad at rounding, okay? So if you're ever sort of unclear about, is it up or down, your best recourse of action is just to actually say what you're doing and why, okay? There's part A. There's part A, or part 1 rather. Now part 2, then they change the rules of the game and they say, okay, now let's look at it as a modified situation. Okay, so they give you this differential equation. Okay. You have to verify that this new equation that they provide to you, which is kind of them, that this equation slots into there. So all you have to do is differentiate and you'll get that out. Don't integrate, it's not the way to go. And then they say, what can be deduced about n and n on dt as t increases? So they're saying as time goes to infinity. Okay, well, here's our n equation, right? So if we take that limit of n, what do you get? What's happened to this guy? Don't forget k is negative, right? K is actually negative. There's a negative hiding in there, right? So what happens to e to the kt? It becomes this tiny, tiny, tiny number, right? So this guy vanishes, so you just get left with 50. Okay. Something I skipped in the previous part was that if you think about the limit here, it just drops off. It goes off to 0, as you would expect that this function does when k is negative. Okay. So that's that limit. You can also think about the limit of the derivative, dn on dt, even though it's not really as illuminating, but anyway. What happens here? Well, I know what's happening to n, right? I know what's happening to n. It's going toward 50. So what's happening to n minus 50? It's going toward 0, isn't it? So the whole thing is going toward 0 because k is just a constant. There you go. So what this tells you is that it's leveling off to a sort of to 50, and it's sort of stabilizing there. Okay. Now, what do they want us to keep doing? They want us to repeat this process of finding the growth rate for this situation. Okay. So I've got to bring back my initial conditions, find a new value for k. So I'm going to take this same piece of information but use it on a different equation. Okay. So I'll say when t equals 3, and they actually do start giving you numbers right away. The population is going to be half. Whoops. Okay, so I can pop that into here. Oh, no, I should have popped t equals 0 in first. Sorry. When t equals 0, you start with that, because as you remember, when it's modified, the c is not just going to be 250, is it? I think in this case it's going to be 200. Yes? Do you want me to show you how that works? Or, yeah? Yeah, okay, let's do it. 250 equals 50 plus, there's that c, which I do not know. That's e to the kt, which is just 0 because it's times 0. So this is just going to become c. bring the 50 over the other side, that's where your 200 pops out. Okay? To find k, I need some other point in time, which is where I'll do this. Okay? So I've got 125 over here, 50 here. I just put 200 there. Like so. Okay? So I'll bring this over, that's 75. I might as well divide by 200 while I'm at it. 75 and 200. Take out 25. 25. 3 over 8. So now, skipping a couple of steps because you can see what's going to happen here, I'm going to get a value of k equals, let's see, a third still log 3 on 8. So, slightly off. I mean, this is 4 on 8, isn't it? And this is 3 on 8. So, is this quicker or is it slower? What's the number? You can actually get the decimal out. Again, you get a negative because the population is still decaying. And I think you get 0.33 something something. Yes? So you're getting negative 33%.